Hello, it's Duncan. Up to now, the Gilded Rose stock control system has stored its data in a single file. This is simple, but it means we've had to jump through some hoops to make sure the data is safe with concurrent updates. As we add features, this is going to become more of a problem, so we decided to migrate to storing our data in a proper database. This leaves us with two decisions to make. The first is the choice of database. I think this is a relatively easy decision these days. Unless you have exceptional circumstances, you should default to Postgres. We don't, so we will. The second decision is what technology to use to map between data in the database and data in memory. For me, raw JDBC is too raw, and Hibernate doesn't fit the functional paradigm well. We aren't using Spring. Asking trusted colleagues, the recommendations are jOOQ and Exposed. And I picked Exposed to try out in this episode because it's from JetBrains and they aren't yet a sponsor. Writing some tests is a fine way to gain and capture knowledge about how to use an API, so that's what we'll do in this episode. We'll treat it as an experiment, and at the end decide whether or not Exposed is working for us. If we're going to store data in a database, we need to run a database, and Postgres is the easy choice. I've chosen to run it in Docker, and this is a Docker Composed file that runs up two Postgres containers. One's on 5432, the normal port, and we're calling local database. And one is on 5433, we're calling test database. And the difference between these is that the local database will have a persistent volume, which should mean that the data survives starting and stopping the Docker container, whereas the test database will just use for unit tests, and not having a volume that will lose the data when we restart. These both read configuration from postgres.env, which is here, and just says we've got a user who is Gilded, a password, a rose, and a database called Gilded Rose. And finally, there's a little script here, startdb, which saves me from remembering what I have to do to start up the database. In this case, it's docker compose, pass this YAML file, and say up. So let's give that a go. We'll go to our terminal and run db startdb. And here you can see Docker is pulling the Postgres container. That will be a one-time cost. And now we have two databases ready to accept connections. IntelliJ is a really good tool to look at databases, so we'll go and add a data source of Postgres. Now we need to make this line up, so it was localhost on 5432, our user was Gilded, and our password was Rose. Let's see whether we can make a connection. Oh, that's excellent. And now let's drill down into here, and we can see an empty database. But we have connected at least. Before we go on, we'll copy this and paste it. And this one will be our test database, which is on 5433. And we need to tell it the password again, test the connection. That's good. And we can say OK. So now we have test, and let's rename this one to be dev. OK. I like to use tests to experiment with APIs, so in our persistence test tree, let's create ourselves a new Kotlin class, and we'll call it PG tests for now. And we'll just give ourselves a test. Should really set up a template for that. Hey, maybe there is one, who knows? And let's say test, Alt-Enter, no, tab, no. Ah, well, never mind. Okay, now off to Gradle to work out what to import. A little bit of research shows that we need to pull in Exposed core at some version, Exposed JDBC because we'll be using JDBC as our fundamental connection, and an extension for Java time. The JDBC driver is this Postgres one here, and we'll also pull in a connection pool now while we think about it. So let's import that into Gradle and get back to our test. Everything in JDBC starts from a data source, so let's find one of those. We'll call this data source. And there is a PG simple data source. And we like simple, but that has no parameters, so we're going to have to set things on it to configure it. And we do that with apply. Now I think this will default to localhost and the normal port. So if we just set user is Gilded, password is Rose, our database name is Gilded Rose. Now we tell Exposed about our database schema by creating table objects. So let's have one for our items, which is all we really need to store at the moment. And we'll make it an object because it's fundamentally singleton. There's one of these that corresponds to our one database schema. This is going to be a table. And now properties of this map onto our schema. We don't have a schema yet, but let's push on. We'll say, let's say we have an ID. It's going to be a column, and we want it to be storing strings. And then there are methods here, so we can say something like varchar, the name of the column in the database, and the maximum number of characters. So we'll say 100. And I should probably call that items. Now Exposed has a schema utils, which will create missing tables and columns. We don't have any tables and columns yet, so we can pass that our items table. Let's just try and run that. Okay, apparently we need to be calling database connect before using this code. We don't have a database yet, so let's just try calling database connect, and that takes a data source, but we have a data source. Let's try that. Now we have no transaction in context, and I do happen to know that we have a transaction block that looks like this, and we can run our code in that transaction. Let's try that. Okay, that passes. Let's go and have a look at our database. Now, this is the default, so it was 5432, so that's our dev database. We'll fix that in a minute. Now, for some reason, IntelliJ doesn't show all the tables by default, so we have to click here and say, I want to see our Gilded Rose database. Turn the others off. And now we have to say, I want to see my public schema. That will show our items table with our single column. While we remember, we'll just do the same here, adding in Gilded Rose, turning off database, and saying, show me the default schema. So now we have a table. How do we add things to it? Well, in a transaction, we can talk to our table object, which is items, and say insert. Now in this block, the parameter, by default it, has an index operator on it that we can give the table IDs. So here we can say ID, and we'll pull the ID column from this table. And as that's a column of string, we can assign that to an ID. Let's just try that. Well, it passes. Let's have a look in our database. We can double click here to look at the table. And there we are. We have an ID. Brilliant. Now what about reading? Well, again, we need to be in a transaction, but we can say items dot select all, and we can map that where each item is a result row. What can we do with the result row? Well, again, we can index with a column from our table. But in this case, we have to say items.id. And that will be a string, which we could print. Let's run that. And here you can see that we now have two IDs because we've run the test twice and we haven't cleared out the database. Well, that's going to confuse things. Let's clear the database between each run of our tests. That's a good use for a before each, but we'll also need to make sure we have the tables and columns. So I think what I'm going to say is that we could pull this data source and the database out into the top level. There. Now this reveals a problem, which is this database connect data source. We weren't assigning it to anything. What was actually happening before, when this was back in here, is this database connect was setting a thread local that could be read in this transaction. I don't like that, but it turns out that there is, if we were to assign this to database, a version of transaction that will use a specific database rather than the thread local. So let's do that. And now we can pull these two to the top level. And I think potentially share them with all of our unit tests. Now before each test, we want everything to be clean. So we can say at before each, we'll call this resetDB. And this is going to say we need a transaction from our database. And we can go to schema utils again, and we can say drop our items, and then create missing tables and columns for items. That will clear our database every time. And now our test can concentrate on adding an item and finding it. And if we run this, I think we should only have one an ID. Let's find out. You saw it there. the single ID that we created here rather than ones from previous runs. Now we don't just want to be storing an ID, of course, we want to be storing all the information from an item. So let's remind ourselves what that looks like. So items have an ID, a name, which has been non-blank, a sell-by date, which is optional, a quality, and a price, but the price we only fill in afterwards, we're not storing that in our database. So let's return to our tests, and in here we'll build ourselves an item. And we had this item constructor that I called item for test last time, and that annoyed me so much that I just returned it to be called item. Now this will take an ID and the name, a sell-by date, which is a local date, 2023 to, and it's the 14th today, Valentine's Day, and a quality, which is an int. So we'll need database columns for those things. Go down here and add them in. So we'll have our name. Well, that will look a lot like our ID probably. Now our sell by date, we want to be a column of local date, but nullable local date. So it's a local date question mark. And there's a date, which we can give the name, and we have to import. And you know, this doesn't compile, and that's because this date returns a column of non-nullable date, but we can say it could be null by saying nullable. Before we go on, I just noticed that is wrong. And now finally our quality, we want to be a column of int, so that's an integer called quality. Now in our insert, we can take item.id, and that's one of our tiny types, so we're going to take the toString of that. The name is going to be item.name. Again, we'll toString to get the value out of it. It, a sell by date, it's going to be our item sell by date. Note the nullability works. And it, quality, is our item.quality value int. Let's run that, see if it works. It does so far. We'll drill down into our items, and you see we've changed the schema, and now we have ID, name, sell by date, quality. Excellent. What about getting them back out again? Well, what we really want here is our red items as a list of item. In order to do that, we'll have to return an item in here, and we can do that at the moment with our item function. And we can pass it the ID that we've just fetched there. And let's just fill in the others. So our name will fetch the name parameter, our sell by date will fetch the sell by date, and our quality will fetch the quality. And in here we can say ID, name, sell by date, and quality. And if we're right, then we expect that our red items is equal to a list of the item that we put in the first place. Run that. Splendid. And now we can pull a function out of here. So let's take that, and we'll call this insert. And now if we make a parameter out of items, then we can turn that into the receiver, and we now get items insert item, which feels nice. Take this to the top level, and that's part of our public API. Run to check we didn't mess it up. Good. And now we can do the same with read items. So if we take this as a method, that will be all. Once we make this a parameter, and then a receiver. Cut that from there, and put it down the bottom. And make that into a function called toItem. Now we can make this into the parameter, this into the receiver, and as this items is a singleton, we don't need to pass it a parameter. Haven't yet found a way to inline it, so I think maybe I'll do that by hand. We'll take that, all of those, and replace them with items. Now that becomes unused, and we'll run the tests. Good, good. Now we're still calling this item here, the one that's in our test data, and we'll basically throw a null pointer exception if we pass in invalid IDs or names or qualities. We can't call this from production code, so let's inline it where we are and then think about what to do. Okay, what should we do if the information in our database isn't good enough to reconstruct an item? Now remember, our standard error handling options are return a null, throw an exception, or return a result type. Of those here, I think null isn't very helpful because if something does go wrong, we're going to want to know what went wrong, which particular field we couldn't pass. A result is appealing because it will communicate to callers that the call could fail, but the fact is there's really not much the calling code can do about it. The best we can do is go and patch the data in the database. We used a result in the case of reading from the tab-separated file because that file could be edited by a user and we'd like to communicate how they'd messed up. Here though, if invalid data gets into the database, it's a programmer that's messed up, us. And exceptions are generally good enough for programmer errors. So I think what we'll do is instead of throwing null pointer exception in these cases, we will say we'll raise an error. And we'll carry on doing that. This cell by date here, its type is local date. Exposed will already have thrown an exception if it couldn't convert the string in the database to a local date. So we can leave that one alone. And finally, if we find ourselves getting these errors a lot, I think we'd probably want to put the ID in here and so on. But at the moment, this is just doing due diligence. I think we could probably inline these. As those errors shouldn't occur. That leaves us with an expression. This error handling code is untested. I think if we were introducing this into an existing production system, I might want to add tests, but at the moment I'm quite sanguine. But let's run the test we've got. Good. Okay, so now I think we're in a position to write a traditional repository pattern items class. So let's maybe rename this to be items tests. And we'll leave the test we've got, but we'll add another one here. And for now, I'm going to call this repository until I have a better idea. Now, I think I'd like to call this type items, but at the moment, that name is taken by this items object. So let's just rename that to be items table, but we won't rename the test. Okay, let's sketch out what we want. I'm going to be able to create an items. I don't really know what to pass this at the moment. I feel like I should pass it the database, but then the transaction here is the thing that binds with the database. And we want a transaction to be able to span multiple operations on items. So let's just leave it alone and see where we go. Okay, if we have one of those, we'd like to be able to say expect that items dot all is empty when we have an empty database. Let's build some things. Let's make an items class. That seems to be bound to something. Let's have a look. ComSun Tools Java C JVM. Not very helpful. Has that been imported? Yes, it has. Let's delete that. And watch it come back every time. Thanks, IntelliJ. Never mind, we will add ourselves an item type down here. So we say class items. Let's see whether that allows us to delete this. Well, at least it's not used now. Okay, we know that we want an items all, and we'll make that a member function, a method, and it's going to return a list of item. And if we just say to do in here, then we can run all of our tests. Okay, that fails with our to do. But in fact, we know how to implement this now. It is return items table all. We run that. Well, that still fails. And now it fails because we don't have a transaction. Well, we knew that, so let's go and just take a transaction block and wrap it around our call. How to manage this transaction is a problem we haven't yet worked out to solve. But if we run the test, that will pass. Okay, so armed with that, we can say items add, we'll give it one item that looks like this. This doesn't exist, so we can create a function for it. And we know how to do that because it is items table insert item. Now, rather than all this scrolling up and down, I'm going to split this window so that we can see our implementation on the right-hand side, if I remember, and our test on the left. Okay, this will need to run in the transaction. So we'll start another one on the database, add an item, and now if we duplicate that and bring it down, items all is equal to a list of some item, which we don't have yet, but we will if we pull this into a variable. Just check that works. And it does. I think we might reasonably have two items, item 1 and item 2. This can be ID 1, this will be ID 2, this can be another name, and in this case I think we'll get rid of the date. So we'll put a null in there just to check that all works. Make that 99, add item 1 and item 2, and now we can say this is item 1 and item 2, and we expect that to pass, which it does. Okay, I think that makes this add items, or add item in fact. What else do we need to do with the repository? Well, one thing is to look up an item by ID. So let's duplicate this and call this find by ID. We'll create an items repository, add a couple of items in a transaction, and then maybe now in another transaction on this database, we can say expect that items.find by ID given an ID of item, and we'll look for ID 1. This factory, remember, may return a null, so we will just double bang that in our tests. And this should be is equal to item 1. Can't see item 1, so let's pull those out of there. Find by ID doesn't exist, so we will add that as well. This needs to return an item. But we should really be looking at that in the right-hand pane. So let's go over here. Okay, so far we've solved problems by going to the items table, so let's try that. We'll say return items table dot select. That's handy. And now we have a little magic DSL that I prepared earlier. Now, select will be returning a set of things and we only want one thing. So let's just assign that to rows. I'm going to move this over here a bit. Let's have a look at the type of that. It's a query. Maybe we can map on it. Oh, we can. And I think we may be able to use our it to item. Great. And that means that this can return rows first. Let's run the test, see whether that's true. Well, they pass, that's good. But of course, find by ID may not find an item, so it needs to be returned null. Let's add a test there. So here we can say, expect that find ID on no such ID is null. If we run that, it should fail. It does. And now we can say rows first or null to make it pass. Now this of course begs the question of what happens if we have more than one row. And in fact we've cheated a bit because down here we haven't said that this is a unique column. The fact is that at the moment nowhere in our system do we rely on these IDs being unique. They just practically are. Don't know quite how to approach that yet. So at the moment I think we'll say we'll tighten this up later. But right now we'll just say that if rows.size is greater than 1, that we have a to-do, and before we go into production we'll address that issue. So this is handle duplicate IDs. And we'll run to check that that still works as we expect. Okay, this is not rows really, it's items. And I think we could make this else. Good. Before we go on, I'll have a little tidy up here. I think we take these items out of here, and in fact the items, we can move them to the top level of this test to tighten everything up a bit. And that will let us get rid of that, and these as well. And this should be item 1. Should that. Okay. Let's add one more operation, and that's to update an item. So we will take a test that looks like this one, and we'll call this update. So the same pattern, we'll add 2 items. Then in the transaction in the middle, we'll say items update, and we'll take out item 1 and copy it, changing its name to be new name. Okay, that doesn't exist, so we will add it. It's going to be item, and then we'll work on that down here. But before we do, let's just get this to compile. So we need to double bang that as we're in tests. And then we can say that we expect that when we find by the ID of item 1, then that should be our revised item. But let's take this and we'll say we have revised item, update the item, and then when we go and find it again, it should be the revised item. Okay, check that doesn't work by running the tests. And indeed it doesn't, because this to do. Right, it won't surprise you that we'll go back to the items table here and find there is an update. And we want this one with an expression builder. So the expression we're going to use is the same one we had up here, where the ID is equal to our ID. So we'll put that in there. But this is going to be our item. So we're going to take the ID of the current item. And then in here, we're going to have code very similar to this. So in fact, for now at least, I'm just going to copy this. Now we don't need to change this ID, but I'm going to leave that alone because it will mean that we can reuse that block. Take out the to-do and see whether that works. And my goodness, it does. Now, what should update do if it doesn't actually update something, and how do we know? Well, let's have a look at this. This returns an int, which will almost certainly be the number of rows that have been affected. It turns out it won't actually tell us here, but I think we could say, write a test over here. Now in here, I think if we go for an ID that doesn't exist, so let's say ID of no such, then I think this would be a programmer error to try and revise an item that doesn't exist in the database. So again, I think we'll use exceptions for that. And instead of saying it's equal to something, now we can say expect catching. This will be our block. So what we want to do in here is say, when we try and update with an item with an ID that's no such, then we should get an assertion error. In fact, I think this will not be an assertion error. This will be illegal state exception. So let's put that in there. It turns out we actually need to say in here is failure before we ask what the failure is of. Run once more, and we are good. I think we're now in a position to remove this test here that just works in terms of the items table. So let's get rid of that. And I think we're probably done for the day. Looking at what we've ended up with, it's a little bit unsatisfactory. I think part of the problem is that all these operations could be moved to extensions on item table. So really here, items isn't adding much value at all. Although we can use it to implement an interface, which isn't something we can do just by adding extension functions. So this would be our route to having an in-memory items and a database items, for example. There's also something very strange about the fact that this transaction is associated with the database and propagated into the code that we're calling here. So I don't think this is a finished design, but writing the test has allowed us to capture the knowledge that we have of Exposed as we're gaining it. In the next episode, we'll look at integrate Exposed into our production code, and with luck, that will tease out how we should be handling these transactions. If you'd like to see that episode, then please subscribe to the channel. And if you're interested in learning my particular style of Kotlin, then you should check out the book that I wrote with Nat Price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. And finally, my workshop at Kotlin Conf in Amsterdam in April is now sold out. But if you'd like to hire me to run the workshop for your organization, then please do get in touch. Thanks for watching.